Okay, today we're going to talk about how to graph piecewise functions. So we've talked about how to evaluate them, now we're going to talk about how to graph them. I'm going to show you two ways to do this. The first one is just almost easier in some ways, but it takes longer because you're going to set up two tables, or a table for each piece. So if you had 4 pieces, you would have to set up 4 tables. So the second method is we're going to just graph and then erase. So depending on your skills or the way your brain works, hopefully between one of these two methods you'll be able to use it and do well. Let's take a look at number 1. So what I'm going to do is I'm going to label these as piece 1, piece 2. So here is my first piece. I'm going to use blue to represent that first piece, and then I'll use purple to represent the second piece. So table 1 for piece 1. What we're going to do is we're going to say we have f of x, x, and f of x. So we're going to make a table. So x, f of x. And what I'm going to do is I'm going to look to see where do I start. Well, I start for all the values of x that are less than 2. So 2 is my starting point. So because 2 is my starting point, I'm going to make a note to myself. Am I going to use an open circle or a closed circle here? So because there is no equal to symbol here, I'm going to use an open circle. Now, what are all the x values less than 2? Because for a table, you should probably have 3, maybe 5 numbers. We're going to do 3 for our sake. But what are 2 other numbers less than 2? Well, let's just choose easier numbers. So 1 is a number less than 2, and so is 0. If you wanted to do -1, -2, whatever you want, you can pick any numbers and it'll work. I try to pick the next closest numbers to make it a little bit easier. Now what we need to do is figure out our output. So if our input is going to be 2, 1, and 0, what is our f of x? What is our output going to be? So we have to plug those in to this first piece. So I'm going to plug each of those in here. So instead of a negative x plus 2, if x is 2, I'm going to say, what is a negative 2 plus 2 going to give me? Now, negative 2 plus 2 is going to be 0, meaning that we're going to put a point at 2, 0. Now, what about when x is 1? Well, when x is 1, I'm going to have negative 1 plus 2. So what is negative 1 plus 2? Well, that equals a positive 1, meaning I'm going to have a point at 1, 1. Finally, the last one, just so we can have the direction that this piece is going to go, we're going to take a look at 0. Negative 0, well, that doesn't make sense. That's just going to be 0. What is 0 plus 2? So that equals positive 2. Now, we know this is going to go forever and ever and ever in that direction because I can find a lot more numbers that are less than 2. It could be negative 10, negative a million, negative infinity. So we're going to draw an arrow going in that direction, showing that it doesn't just stop with these 3 numbers. We just chose these 3 numbers so that we could connect our points with a line. Now, let's go ahead and plot these. Remember my note. So my note is saying I'm not going to plot a typical point here, but because it's not equal to, I'm going to plot using an open circle. So at 2, 0, because when my input was 2, my output was 0 after I plugged it in and solved or simplified. At 2, 0, I'm going to put an open circle. It's kind of like my starting point. That's the end of that piece. And then I'm going to put a point at 1, 1. So 1, 1, just going to put a point here. Some people think, well, shouldn't that be an open circle? You only do the open circle, a closed circle thing for that first piece, the end of that piece or the start of that piece. Finally, I have 0, 2. So 0 is right here at the origin. I'm going to go up to and put a point. Now we said we can go all the way forever to negative infinity. So I'm going to draw this line, and that's going to go forever, that piece. So the piece starts here at 2, and we're going to work back to negative infinity. Now that's just piece 1. So I know the tables take a while. I'm trying to go slow since we're doing this for the first time. Now, what about table 2 or piece 2? So piece 2, I'm going to go over here and use for table 2. So we're going to make, again, our x, f of x table. Now, where's my starting point again? I'm starting at 2 again, but this time I'm going to put a note that I'm going to use a closed circle because it can be equal to 2. So because my starting point's 2 but equal to 2, I'm going to just put a note here. I'm going to use a closed circle as my starting point. But now when I want to find my next 2 numbers for the table, I need 2 more values of x that are greater than or equal to that value of 2. Well, what are the next 2 numbers on the number line? We have 3 and 4. So now that we know our starting point of our piece, we found 3 numbers, or 2 additional numbers other than our starting point that are greater than or equal to 2. Now we're going to plug those values in so that we can get our output to see, we know what the x values are, we're going to use 2, 3, and 4, but what are my y values? So that way I have a point to plot. Let's go ahead and talk about that. So when I replace x with 2, what is 2 minus 2? Well, we're going to get 0, so this is going to be 2, 0. When I replace x with 3, what is 3 minus 2? Well, that's going to be 1. So I have a point at 3, 1. Notice I'm not showing the same steps that I did here. I wanted to show the steps so you wouldn't get lost, but here I'm going to skip that part. Now, what about when I replace x with 4? What is 4 minus 2? Well, that's just 2. Some of you might notice the pattern, 0, then 1, then 2, so you can guess that this would be 3. So 5, 3, 6, 4. So let's go ahead and plot these. Remember my note that I'm going to make a kind of a larger closed circle. So 2, 0. So 2, 0, I'm going to have a closed circle. Remember, when an open circle and a closed circle overlap, the closed circle outweighs it. Now, I need the direction. I don't know where my other points are. I need to figure out how can I draw my line. So 3, 1 gives me an idea of where my next point's going to be. 4, 2. So now I know that the direction this is going to go this way, and that's going to go on forever again because numbers larger than 2 or equal to 2 can be 5 and 10 and 100 and 1,000,000, all the way to infinity. Now what we're going to learn later is that this is actually an absolute value function, and it's shifted over to the right too. But we're not going to worry about that right now, but very interesting that piecewise functions can also be used for absolute value functions. Now over here, number 2, let's just do another example. I'm going to show you a second way to do this. Now the second way, so the first way was draw a table, so you're going to make a table for each piece. The second way is you're just going to graph them just as you see it. You're going to kind of ignore this for now, not forever, but you're just going to first graph the first piece. So we have y equals mx plus b, so my m is -4 and my b is a +5. So that b is that starting point. So I'm going to go up 5, and there's my starting point. Now, this slope is telling me, hey, I'm going to go down 4, remember the direction, down 4, and we can write all numbers over 1. So I'm going to go down 4, 1, 2, 3, 4, and then to the right 1. Down 4, 1, 2, 3, 4, right 1. I don't have enough space to do the next, but you get the idea. So what we're going to do is just kind of lightly graph or draw our line through our points. Okay. Now this is where we graph and then erase. So I hope you're not doing this in pen, because we only want the x values starting at 1. Well, on my x-axis, where is 1? 1 is right here. Now, I only want the x values starting at 1 and to the left of 1, less than 1, numbers like 0 and -2 and -5. So what I'm going to do is I'm going to take my eraser, starting at 1, and I'm going to erase everything I don't need. I only need the piece starting at 1 and going to the left. Now again, depending on how your brain works, this might not be easy for you, so you can stick with the table method. If you feel like the table is kind of hard, then maybe this would help you. If you feel like both are hard, I would just YouTube a better teacher than me, honestly, and then you'll figure something out. Now first, this point here, should we have an open circle or a closed circle? Because it's equal to it, we're going to use a closed circle. So that's the beginning of this piece, and now I'm looking at all the x values that are going to the left of that. All right, now, what about the second piece? So this takes less time, but you have to be able to see it. X squared. Some people don't really know what the graph of x squared looks like. I'm going to go ahead and graph it if you want to kind of look that up on your own, or if you want to create a table from -2, -1, 0, 1, and 2 to see what x squared looks like. But this is the shape of a parabola, and so we're going to have points here like this, 2, 4, 2, 4. And so a parabola, it's just this kind of like U-shaped graph, right? Now, we're trying to figure out, okay, which piece of this function, this graph, are we looking at? Now, we're looking, again, starting at 1. So let's find when x is 1. So we're starting at the same spot, but notice we would use an open circle. Now, what happens is the open circle and the closed circle, they collide, and so the closed circle kind of outweighs that. Now, which piece are we looking at? Are we looking from here going up, or are we looking from here going around to the left? So let's look. We're looking for all the x values that are larger than 1. So where are my x values getting larger? It's as I go to the right. So the piece that I care about is this all the way over here to the right. So I'm going to very carefully erase everything that goes to the left. So here is our second piece. So this piecewise function, we have a closed circle starting at 1 for my purple piece, and that goes over to the left because I'm looking at all the x values going to the left. So we had a straight line. And then my second piece is the right side of a parabola starting at 1 with an open circle, and it's going all the way to the right. Now, piecewise functions are typically something that's challenging for students to graph, but we will continue to practice, or hopefully you'll have more practice and get some more help if you need it.